Okay, we're about to do question 8. I hope you had no problems with the other questions up to this point, and either 9 or 10. If you do, just please email me and we see if we can work our way through that. But in question 8, it's slightly more complicated, so I thought I'd do an entire video just on its solution. So looking at it, we've got a 60 kilogram mass here, and it's stationary on an incline. Okay, so if it's stationary, then we've balanced our forces on this incline, and it's attached to a rope. And because it's a rope, then there will be a force in this rope, and that force would be obviously called tension. So let's do the 5 questions that it's asking here. So the first thing we're going to do is we're going to draw a diagram to have a look at this. So the first thing we're going to do is just do our incline, and it's a 25-degree incline. And here is our mass. We'll put it slightly further up this time from this. And there would be a force this direction up the plane, and there'll be a force down the plane because the object is not moving. There's also a normal force at right angles up here, and this force will be countered by a force down here, which is mg cos theta. Okay, this one here is mg sine theta. And this one here is the weird and wonderful force that is going to be created by another force, which is a tensional force up here. So that's a rope being pulled there. Okay, so before we go any further, let's have a look at the question. The first question here is calculate the component of the weight force acting down the incline. So this is our standard question. So this is the mg sine theta. So question 8, part 1, just check that we've all got, you can see that. 8, the one down the plane would be mg sine theta, and this theta is 25 degrees, and the m is 60 kilograms. So it's 60 times 9.8 times sine of 25 degrees. And calculating that now, we've got, let's do 60 times 9.8 times sine of 25. That's 248.5. So it's 248.5 newtons going down the plane. Okay. The one up the plane is this one here. This is the one that must be equal to this one here. So what is that one? Well, this is the tensional force there. So that tensional force is the one going up there. And this tensional force can be resolved into this force and that force there. Okay, where this angle in here, we're told, is 30 degrees. So this would be T cos 30. That's that one there. And this one would be T sine 30. So T cos 30, the tension times cos 30, must be equal to that one there. So question number 2 asks us, calculate the component of the rope's force, that's the tension, acting up the incline. So it's asking us this value here. So there it is, it's asking us this one. So T cos 30 must equal 248.5 newtons as well. As a result, we can now do number 3, or question number 3 says, can we now calculate the tension? So part 3, T would equal 248.5 divided by cos 30. And that's 248. I will use that one, divided by cos 30. And that's 286.9 newtons. Okay. I think the rounding, I'm hoping the rounding's not changing any of the values in the answers. Okay. So that's the first 3. Calculating the component of the weight force down the page, so I keep on saying the same page, down the incline, and then up the incline is that one. And as a result, we can now work this one out here. Okay. Now, what is this rope doing to this force here, to this box? Well, it's actually slightly lifting the box off the off the table, off the incline here, because it's pulling it slightly further up. So as a result, the normal force is being reduced by that t sine 30. So the next questions we're doing is calculating the rope's tension acting normal to the incline. In other words, it wants to find this part here. So this is normal to the incline. So normal, it means at right angles to the incline. Here's the incline. So t sine, part 4, is asking us t sine 30. And that would be 286.9 times sine 30. So it's basically half of that value times sine 30. And that's 143.5 newtons. Okay. So this is 143.5 newtons. Whoops, sorry. Oops, I lost you there for a few seconds. This is 143.5 newtons, pulling it off the incline. So now we're asked, the final question there is, what's the net normal force? Well, the net normal force is the force that is the actual surface is pushing up here. So the normal force would be normally this. So it's going to be mg, that would be the normal one. That would be normal. And it's going to be less than this because this is the amount of force that is actually being pushed up as well. So rather than adding these two forces have to subtract, because n plus t sine 30 would equal mg cos theta, cos 25, because that theta there is at 25. So this plus that must equal that, because it's not rising off the surface. And we want to find n. So n would equal mg cos 25 minus t sine 30. And popping those values in, we got 60 times 9.8 times cos of 25 minus t sine 30, which is 143.5, which we've already calculated before.